just say thank you for being here. Thank you for being here because what you're about to be lectured on is an exam question. It won't be the exam answer that you're about to be given. It absolutely amazes me that in a class of 90, there's probably only about half of you here, but that probably means only half of you are going to pass the exam, not the problem of those that are here. That aside, I would like to introduce to you this evening Mervyn Richards. I normally start by presenting somebody, telling you they're an alumni, they're an ex-student of Greenwich. Mervyn, unless he's keeping it a real secret, I don't think was a student of Greenwich in any shape or form. However, he was with Langer O'Rourke between 1972 and 2004. Whether that's a credible reference or whether that's a penance, I'm not sure, but I'm sure he will mention that. The subject of this afternoon's lecture is BIM. Not only do I keep mumbling the exam question every time I mention BIM, but BIM is integral to your FM learning next term. If you're not quite with it, stick with it, because we will be repeating this over and over again next term. So, without further ado, Mervyn, the floor is yours.
Okay, thank you very much. I think the speakers are on, but I tend to drift away from them, so if you can't hear me, please shout. As has been said, I've been involved in construction for over 40 years, and certainly at least 35 of those years in looking at the use of computers in construction. And this whole idea of BIM, Building Information Modelling at the moment, is something that we really started in 1972. It was a simple idea, was to get three different disciplines sitting around a computer, architect, engineer, MEP, or the MEP and the P, and to fill out all the blanks to a building, and theoretically have two speedometers on the top of the screen, one telling us how much it's going to cost, and the other one how long it's going to take us to build. And that was the whole idea. Feed all the design information into the computer and let the computer analyse what you've done and tell you how it's going to build and how much it's going to cost. This was all about differentiating the company and to look at alternative designs in competition to win tenders. So at that time it was all about how can we win tenders. Part of the problem in those days was cost. And if I could just say, the first computers we were using for a 2-year survey and research into seeing if computers could help us design and construct was around about £60,000 a machine, and the average salary, top end, was £1,000 a year. So we had to be 60 times faster using a computer than we were on drawing boards and using slide rules. Not forgetting at that time the calculator had only just come into play. So we were still using slide rules and still drawing these things. So the computer, we had to be 60 times faster. Well, the answer to the 2 years research was an impossible task. You certainly couldn't do it faster than you could do it on the computer. But what we could do was do it more accurately and come up with better answers. What we had to do was to write our own software to enable us to generate, it was all 3D, to generate 3D models as a byproduct of the design process. So that meant starting in an analysis package, design your network, load it, analyze it, select the section sizes that are needed, hit the button, and it builds the 3D model for you from nothing. That was the concept, and that's what we had to do to enable us to get 60 times faster than we could do it by any other method. And the whole use of this then progressed for about the next 10 years, quite well. And a lot of the software that was developed at that time is still being used today. And you will find as you go out into industry, there are computer programs, certainly academically, for highway design, which were actually generated and developed in the 1960s and grown up into this CAD type world, but they are still fundamentally the same programs that were generated then. Design and produce your model as a byproduct. For computer-aided taking off, there were things called CATO, C-A-T-O, computer-aided taking-off systems, also developed during that program, still being used today, 40 years on. So the work that was done then was quite fundamental, and it did work, and it should have progressed, and it didn't. Because what we had was an economic crash in 1989 to 91, very similar to the one we're going through at the moment, and most of the construction activities and the design houses downsized by over 30% loss of the industry. To cut costs, what they also had to do was to cut out the amount of space they were consuming. So these very large companies with very large space holdings had to reduce those, get rid of anything that you didn't need. So when they came out of the recession, we only had a certain amount of space that we could use to start to build a new industry. The one thing that we couldn't do was go back to drawing boards, because a drawing board with its workspace would most likely be this sort of space, whereas a PC, which wasn't that size, but they were a bit bigger, could consume that much space. So we could get a lot more people into a much smaller space. The trouble was that what also came out at the same time was 2D drafting. CAD, computer-aided drafting. Before that it was CADD, which was computer-aided design and drafting. So we went back to electronic systems that mimicked what we did on the drawing board. They were cheap, they were easy to use. The government also put out money, £300 per head, for anybody that was out of work to go and train as a CAD operator. As a CAD operator, not as an architect, structural engineer, an M and E or a P. So what we had were people that knew how to draw, but they weren't quite sure what they were drawing, how the information that they were drawing was actually derived. The architect, the engineer, whatever, had to put it on a piece of paper and give it to them, and they were more or less tracing information into the computer. But it was very cheap at that time to do that. So all of the work we've done in 3D modelling, what we now know as BIM, is actually called PIM, Project Information Management, suddenly went back to 2D drafting, back to the drawing board. Electronic. So what I'd like to do, having given you that quick background, is to actually try to define what modern BIM is. As I said, it came from PIM, moved into BIM, being sold to us by the vendors, and sold under the title of Building Information Modelling, where before that it was Project Information Management. So what they're selling us is a product that can produce a three-dimensional model with all of the visualizations you like. You can walk through it, you can show your client, you can sell the project. And that's done right at the front of the project. And that's where BIM, as is being sold by the vendors, really sits at the moment. It's their marketing tool, and it's a business marketing tool to win projects. So many projects are won under the title of BIM that are then produced in 2D even today, and then they ship the drawings out to India or China or wherever to have somebody build a 3D model for them so that they can say that they are doing BIM. That is not what we are going to talk about today, and it is not what is being put out at the moment and mandated by the government as client in getting rid of the waste and reducing the cost in construction. Yeah. So BIM, in this context, is the one that you can see here. BIM means the combination of all of the discipline-specific models. This is not just with the professional designers, but also with the specialist designers, as well as all of the attendant information that goes with that 3D information model. 3D objects representing how we construct parts to put in the building, but attached to them is all the information that can be gathered. First of all, to tell us whether we can build it for the right price. The next is the sort of information we need to fabricate it and construct it. And the third part, data and the information attached to this model is growing exponentially as we come to the point of handover. To hand all of this information over into FF, into the asset model. Where you will be mining that information to help to cut down the costs in maintaining and running that building, that business in reality. So data is king in this particular situation. So for you, BIM means collecting all of the information from a holistic environment, that is from everybody in the supply chain, delivered to you at your doorstep, ready to use. Unfortunately, one of the things that we haven't yet sorted out is that information that's going to be given you of such a nature that you can really trust it to make decisions on. So first of all, we have to get rid of a problem. And we have to accept that there is a problem in our industry, that these tools and the processes can help us to get rid of. And that's really what I'm going to do this evening. So it's the information plus the model, not just the model. It is also, and I'd just like to clear this up, in some of the tools that are being sold out there at the moment, the idea is of a single model. This is impossible to achieve. It doesn't matter how big the cloud is, or how big the pipe is and bandwidth is on your communications. If you have it all in one single model, the speed at which you can work, and I have seen people sit there and just click and digitize on the screen and go and get a cup of coffee and come back. You have to manage this process, you have to manage the data, and you have to construct the data in such a way that the tools that you have available to you will work at the optimum speed. And that's what a lot of the stuff I'm going to be talking about leads us towards. Okay, the second biggest problem is an understanding of one of the biggest problems that we've had in construction forever. It really goes back, and the first reference to this is 1905 by the Royal Institute of Chartered Surveyors in one of their annual general meetings, where somebody reported that all information invariably from the architect is inaccurate, incomplete, and ambiguous. And that causes waste. Waste in construction costs time overruns, and they are normal, and nothing has changed since 1976, called the advent of accurate CAD tools. I've actually taken you back to 1905. Between 1905 and 1976, everybody knew this was a problem, but nobody did anything about it. Certainly the two wars, 1914-18 and then the Second World War, the Ministry of Works actually looked and studied this problem of waste, because obviously coming out of war years, they needed to make sure they built things once and not 1.5 times or 1.3 times, as the case is at the moment. But because of the tools that they had to work with, they couldn't really do too much until we got to around about 1976. The tools that we were using, I mentioned drawing boards, ink, and we were drawing on linen. Linen with a wax oil coating. That's pretty hard. Lovely stuff to work with. But you had one big problem, and that is, as you drew the lines in ink, they had to dry. And I'm a lot older than I may look. The offices in those days were not heated that well. And it took a long time for the ink to dry. So it slowed us down in the number of changes that we could actually make to the data of information that was going to be used on the construction site. And so that held us up, and we were continuing to produce inaccurate, incomplete and ambiguous information because we just didn't have the time to generate it because of these technologies. After 76, with the advent of accurate CAD, nothing changed. We still produce the information in the same old way that we have been producing it before, you're just using a different tool. But still, all the inaccuracies and incompleteness and the ambiguity were there. Nothing changed. We're still getting that increase of 25 to 30% of waste in the industry. So the question now is, can the BIM tools make a difference on their own? And the answer up to now is no. They make no difference whatsoever, because people are still using those tools in the same old processes that they always did, that produced incomplete, inaccurate and ambiguous information. 1973-76, what really started this whole thing was a report by the BRE. There were two documents produced out at Garston, at their offices in the building research establishment there, where they were putting up 40 buildings post-war, and what they decided to do was to go through the whole process of the design process, fabrication, manufacturing and construction process to see what errors there were and why they occurred. And all of those errors were put together and into these two reports. The main thrust at that time was spatial coordination of information. What that means is, would things fit when you got onto the building site? And the answer was 25 to 30% of the time they didn't. And so you had to make a change on the site. Ambiguous information then comes into play after that, because everything that's attached to that bit of information is now wrong. Yeah. The door is not there, it's over there, the window is not there, it's up there, and everything that then relates to that window or that door is also wrong in some way. So these documents actually laid out all of the problems that we were finding continuously being produced. The discrepancy of 10 millimetres in one dimension cost on one project £3,000. That's one dimension. You think of all the possibilities, all the dimensions that you have to put on a building to build it, how many times that is going to occur if waste is generated at 20% of the actual cost. So there's £3,000 keep adding up, adding up, adding up. So this was produced, published, and everybody read it and said, what a great document, understand that, yeah, it's always been like that, and so what I'm going to do, I'm going to put it safely on this top shelf, and I'm not going to do anything about it. 1982, Sibsey also did, a research into this area to see if things had changed between 1976 and 1983. And the answer was no. Document had gone up there, people had read it, gone up there, not done anything about it. So now we have even more information coming out in this document. Lack of spatial coordination in uncoordinated MEP documentation produces cost overruns of 40% or more. I can tell you when this figure was done 10 years later, the amount of time that was measured wasted on site, that is people once they got to site, the amount of time that they were wasting was around about 50% of the time that they were on site, standing around trying to figure out which was the right document, the right drawing to use. The story I'm telling is, even with the use of computers, the problem was getting worse, not better. In fact, a lot of research has demonstrated that whilst most of the industrial use of computers has benefited by about 20 to 25%, cars, aeroplanes, manufacturing, whatever, the construction industry, the use of computers is actually 10% negative. We're actually taking longer to do things than we used to. So are these BIM tools that have been sold to us in themselves going to make any difference? And the answer at the moment is, it seems not. So going back to this little thing, information is invariably inaccurate, ambiguous and incomplete. The Construction Project or the Coordinated Project Information Committee published this. And they also published this. These are two drawings of a project, a live project. Both of the drawings have been signed off as fit for construction. In other words, somebody has supposedly checked those drawings. One is the architect's drawing, which is the one in blue, and the other is the structural engineer's drawing, which is in red. Now these are CAD drawings. So why, when we overlay them, do we still see the same problem that we used to see on the construction site when we used to stick two drawings one on top of the other, stick it on the site cut wall, window, wait for the sun to shine, and we could see what the problems were. Here we are with CAD, exactly the same problems were occurring. Why, can anybody tell me, is the structural engineer redrawing something that the architect has already drawn and can give it to you for nothing in a CAD file? Why are they redrawing it? Because those same old processes and methodologies are so deeply embedded that they continually redraw other people's information because they don't trust it. This turns up on site. What have we got now? To get the inaccurate problem, we've now got ambiguity. We're now on the telephone. As the document says, 40% of the time saying, which one do I build from? That increases the cost of the building by a minimum of 20% and increases the time to deliver by 20%. The importance about this delay is, in a normal project, let's say somebody just wants something built, let's get it up there, it's an annoyance. I've got to pay more and I didn't get it on time. However, if the project that you're building is actually commoditised in the terms that if I don't get it on time, I cannot earn something with it. So if it's a retail park, shopping mall, whatever, if that isn't up and running 2 weeks before Christmas, I am going to lose a lot of revenue. So in fact, the 20 to 25% starts to become a little bit insignificant. Because it will grow. The losses will grow if things are not delivered on time. And certainly in the early days when we were doing the North Sea oil rigs, we had to hit a window. We had 1 month window in the early part of the year and 1 month window at the end of the year to float those rigs out into the North Sea. If we didn't hit that window, the cost was millions and millions of pounds per day. So we had to come up with some way, some method of getting rid of this ambiguity and producing good quality information. And that was developing a process to use these tools in the best possible way to end up with the right result, at the right price and at the right time. Just 2 other little things here, because spatial coordination is one thing. And we see them here in this simple thing, clashes and lack of registration. Why would anybody, once again, the structural engineer, the architect on this one, sorry, is in red, and the structural engineer is in blue, opposite way around. Why, when they see, when they overlay those two things don't fit, why didn't somebody shout? My column, my stanchion is now too big to fit into the structure. Mr. Architect, can I have more space? They didn't. This one, lack of change management. Somebody was not talking to somebody else. What happened here, and this is actually Piccadilly Station in Manchester, the architect designed the 2 staircases as 2 parallel flights. Sorry, the architect designed them as the 2 converging flights. The structural engineer, being the simplistic fellow that he is, decides that a much better solution is 2 parallel flights. And when the staircase arrived on site, they couldn't fit it because the edge of the slab had not been prepared to take this change, because they didn't communicate. Nobody told them that somebody had made a unilateral decision. Communication, coordination, and all of these things have generated us towards the whole idea that we must become a much more collaborative environment. We must talk to one another. We must work as a team, even though we work in different companies. So process and a culture, sharing, telling, talking, must be generated. For those that haven't been on site, this is a very simple example. It wasn't done like this on purpose, this is what happens. The MEPs have got on site, the plumbers have got on site, and of course this duct is now running right the way across the slab, so every single pipe that was going to go in under the ceiling had to be site fixed. So all of those red elements was where they had to cut the pipes, rethread them, put in the elbows, and join it all back up together. And this is just one very small area in a building. In fact, the worst one of all is the big red pipe above. Why is it red? Because once you start working on these things and taking them apart in this particular situation, the protective coating goes. And what we usually do, in those days anyway, was to paint it with the red oxide to put back certainly the rust proofing. So they show up quite well. And there are thousands of these drawings about them. Everybody and everywhere I go has got their own. So this is not something new, it has been known and we can generate it, and we see it generated time and time again. So going back to what I said, it's the BIM tool salesman tells us that 3D modelling will solve all of these problems. It will not. Here is a building in 3D. Why are the downpipes clashing with the beams and indeed clashing with the MEP's pipework? I could go through this, there's quite a number of these things here. Why is it that the bends are no longer being supported by those two little green stops? Because somebody changed the design partway through and moved away from a flanged connection to a clipped connection, and didn't bother looking at the effect on the remainder of the fabric of the building, the structural fabric that was supporting it. So they lost the supports. This, the drainage here, is because people just produce their models, do not check their information, just shove it out there for people to use. When you put it together and check it, this is what happens. And out of this, a whole new industry has evolved. It's called clash detection. All of the models on Friday afternoon are sent to a company somewhere in China, in India, in Brazil these days as well, where they clash the models and then send back a list, 2,500 clashes found in the models this weekend, resolve them on Monday morning. This is not where we want to go, it's not the way we should be working. Without a process, this is what you will continue to get. What we want is clash avoidance by process, which I'll come back to. Where we've got now is the Laker report, the Egan reports. I don't know if any of you have seen any of these. Once again, were enforcing what we already knew. The RICS statement, the BRE statements now picked up by Sir Michael Latham, reporting to the government that he believed that the construction industry, if changed and challenged, could save up to 30%. The government as client today, 30 years on, 20 years on, sorry, is conservative at saying, okay, we'll set the target at 20%. We want you to reduce the waste by 20%. Because the government, the country, is broke. It does not have the money to waste. And so the government as client are no longer willing to pay for the waste that our industry generates. And why should they? Would you pay 25% for something because the person or company that was producing products for you was rubbish? So why should the government do it on our behalf? So they're now standing up and saying, we no longer are willing to pay for the waste in CapEx. But what we also mean politically is to be able to manage carbon and the waste in operation in OpEx. So there's a two-tiered activity going on here. Reduce the waste in CapEx, reduce the maintenance costs in OpEx. Back to you guys. So what they want us to do is the need to reduce risk and costly errors, to reduce waste in design, delivery and operation, reduce escalating project costs, deliver time to deadlines, manage the effort life cycle, increase competition and into the global marketplace and growth. I could have put a lot more up there. It's just to throw the sort of things at you that we have to change. We look at the bottom two, which is the more interesting political drive at the moment, and that is we want increased competition, which will hopefully drive the price down. People have to get more competitive. But in doing that, it will allow us to get into the global marketplace, and that means growth for the country. Sorry about the political bash, but I am looking at and working for government in putting this stuff out there and using BIM and reducing these costs. These are some of the deeper messages, and it's important to understand them because a lot of people will tell you when this government comes to an end in 2 more years, 3 years, all of this will be dropped. It won't. Because we have an underlying need to continue this and to deliver good quality information into OpEx and to reduce cost. In fact, what's happened now is the UK is now seen to be the leaders in the use of BIM as a holistic process, not in just using CAD tools. We've moved right up to the top. We are now seen to be the leaders in the way we are implementing this. To such a degree that Germany a couple of weeks ago, last month, has actually also taken up the idea of mandating these processes. The first Norwegian organisation actually passed their BIM tests at some lectures and some educational processes and stuff that the BRE are doing. So Norway really wants to do it as well. I'm working in the Far East, in Malaysia, and also it's being looked at Christchurch, in the rebuilding of Christchurch, with the New Zealand company after the destruction that went on there. So this thing has now gone global. And that means we can export our knowledge and our capabilities. It's jobs. Out there, it's work that we can do much better, much faster than others. It is about growth. So, I said, we keep doing the same old thing, using different types of tools forever. And as Einstein says, madness is to continually do the same thing in the hope that the outcome will somehow be different. It won't. A lot of the tools that we've got in the marketplace is actually been built on the old processes in the old methodologies. It's an electronic drawing board in 2D or 3D using the same old methodologies that you always did. We have to change completely, and that's what the government trust is all about. So to eliminate waste in the whole process of design, construction, production information, we must change and we must manage what we're doing. Best industry practice must be used. BS 1192-2007 is the only method that has been tried and tested and measured to actually save money and time. It was actually born out of a thing called the Avanti program, where the government decided it would spend far too much money on research in the construction industry, and everything that had been produced had been put up on the top shelf. So in 2004, they put out some money to say, if somebody would please take all of the documents off the top shelf and apply them in a project and tell us that they really do work and measure the outcomes, we will give you some money to do this. And they spent £1 million on quite a number of projects putting these processes in place, and every single one of those projects saved money. A minimum of 10%, 50% of what the government is now asking for. And those processes were taken up by the BSI, the British Standards, and produced as BS 1192-2007. That has now been expanded to a PAS, PAS 1192 Part 2, 2013. Very quickly, a BS is best practice. It's reportage in a way that somebody has written down what the industry is doing, and it has been proven to be right, and it is measured to be correct. It becomes a British standard. A PAS is a privately available specification, or a publicly available specification. What this means is, here is a specification we suggest you use, and we can then measure it to see whether it actually works and saves time. In 12 months, you have to have it in use for 12 months, we can rewrite it, and it will become the PAS 1192, BS 1192 Part 2. So it is on the journey to being a PAS. The BS 1192-2007 has already been taken up in Europe and will be moved to an ISO, and is an international standard during the next 12 months. So what we're doing in the UK is going out there worldwide, certainly into nearer Europe. BIM standards. As I said, what we're trying to do is to get into capital expenditure, spatial coordination by process, improve quality of production information and SRFIs, reduce project costs, etc. And in OPEX, the exploitation of valuable data that the process provides to be used by the activities downstream. And that means asset management and facilities management. The more accurate information you've got to play with, the more decisions and the better decisions you will make on behalf of that project, that building, in maintenance and asset use through its life cycle. Sorry, it's my phone. I was going to say, is it somebody's phone? It's mine. where we've come from, and this diagram is quite interesting. This is the diagram, known as the wedgie, that government picked up and has decided to go with this, and it's become quite iconic around the world. What it actually shows is the progress of CAD, the technologies in trying to overcome this problem, when it was just CAD, computer-aided drafting, didn't do too much, moved into 2D, 3D, BIM is not a pretty picture, because that was all that was being done at that time. So at level 1, not much difference than we were doing in 2D. And now we're moving to level 2, which is where we want to go, where these processes must be used and embedded, and the software needs to change to allow us to do better things. So the vendors have also got to come on board. At the moment, those little vertical silos represent the architectural information model, the structural information model, the facilities information model, etc. And the one at the end, which I really love, is BRIM, because we also have a bridge information model. So you can have any type of information model you want. It doesn't really matter. The fact that they're standing vertically says that they cannot talk to one another. Interoperability between products is so bad that we can't actually share our information freely. So what you end up doing is either having a project where everybody uses the same software, or you find some other way of sharing your information and using the processes of overlaying and reusing. What we need the industry to do is to give us better software, different software to what we've got. We also have a whole series of standards, the CPI stuff, Avanti, which I mentioned earlier, BS 1192, PAS 1192, PAS 1192 3 and 4 is also just being written, etc. And these are the documents that are being produced by the BRE, by the BSI, BRE, CICP and the CIC up to this point here, which is what the government is asking for, the delivery of BIM up to level 2. The reason for showing you this is that everybody who wants to market themselves, the same as the vendors are marketing themselves, are out there telling everybody, do you know what? I'm at level 3. Nobody can actually achieve level 2 at the moment. For a very simple reason, and that is we haven't completed all of the documents, and they will not be completed until next Easter. So there is a journey that everybody should be on, and everybody is in the same space, and everybody is moving along at the same pace. So anybody tells you, I'm doing level 2 or I'm doing level 3, to differentiate themselves in the marketplace is wrong. They are just kidding themselves and others. That level 2 is what the government has asked us to do. So PAS 1192 extends BS 1192 207. It's a bit meaningless at the moment, and I'll come to it in a moment. It defines the method and the documentation required to define level compliance, and the process is equally usable. This is where we get into big problems in our industry, that the builders, the vertical and the flatlanders, the infrastructure start arguing with one another that for some reason or other what they're doing is different to something else. This is all about construction. It doesn't matter whether you're going up or whether you're going along. These processes work everywhere. BS 1192-207 was actually developed on rail projects and then upgraded to work with buildings. So the argument out there is this works for both environments. It is all the same process. The 7 documents that you require to get to level 2 are CIC BIM protocol, which is the legal and contractual conditions that need to be set to allow people to work together properly. And there are big problems. People say, I can't work with you because I am not going to let you have a copy of my information because you might change it. I don't quite understand this. Because one of the first things we were taught when we were printing paper was actually how to cut out the corner of a drawing sheet and superimpose our own drawing sheets in there with a bit of sellotape and then reprint it. We were stealing information from one another all that time ago. What we didn't have then, which we have now, is an auditing capability within the software that will be used to manage this process. So we know who generated what, to see if anybody's altering somebody else's information or indeed stealing it. So you need this list of drawings. These slides will be available if you don't get it all written down. And additional information, CIC Scope of Services for Information Management. This is a new requirement, although people have been doing it for a long time, it's now being emphasised. This is not about the modelling, this is about information management, the management of the process, not the management of the tool. Sorry, very dry down there. Okay, so one of the documents that's now come out is the PAS 1192-203. As I say, this is a specification for work. What it actually does is sets up a legal framework in which all of those 7 documents that I've just shown sits. So if you can get a copy of this, if you haven't got a copy of it, they're all free of charge. And you can find them on the BIM Task Group website or on the CIC, the Construction Industry Confederation website. Okay. One of the barriers to getting standards used is that somebody says they're too expensive, or they do cost money to generate. So what the government decided was it would pay for these to be written and it would make them available for nothing. No excuses for not using them. In fact, I'm not quite sure that even if you wanted to look at BS 1192-2007, you can either buy it in a guide form from Amazon or in its shorter form for £180. But I think most universities have a license with the BSI. So you can actually, I'm sure, through your library, get copies of those documents free of charge. Is that yeah, okay. So no excuses. If you want to find out what's going on and how to do this, then those documents are there to be used. The main purpose of the PAS is to ensure that the employer and those tendering for projects fully understand the needs of that project, no surprises. One of the things that comes in the tendering process is everybody tries to be clever in seeing something where they can make money. And so everybody that's tendering usually finds something slightly different, and then you get different prices coming in, whatever. When they win the job, what they do is they then try to make claims for any changes that are coming about. This also accelerates the cost. So this process is being set up right from the beginning, that the employer has a responsibility to make sure that the brief is as complete as it can be. Everybody is acting upon the same information. Everybody answers the same questions, so it is a level playing field, and there will be no surprises once the project starts. There will be no things that have been left out. A change in the government as client having now to become an expert, which he wasn't before. So not only has industry got to change, the government as client is also changing. There are teams of people in government, in the Cabinet Office and in with the ministries that are now educating the client to understand what their responsibilities are in making sure that they put out much, much better specifications and tendering information to the industry. And it's known as the Employer's Information Requirement. And it is a document that's necessary under PAS 1192. BS 1192 is really the core of the process. This is the BSI, which is so thick, and the other one is the guide, which is the one I'm showing here, which is a little bit thicker. Everything is there. It does go through it very slowly and very carefully on what we have to do. We'll have a look at something very quickly in a moment. The BIM protocol. The barriers that people put up to say they cannot collaborate, they cannot share information, has been set to one side through the legal and commercial document known as the BIM protocol. You can share information. I can't share my information, but you may change it. Know the process that we know as BS 1192 ensures an audit trail. We know who did what, where, and when. Yeah. We also know if something opens it and steals some of your information. We have a problem that a lot of companies don't want to share their live models, which you have to do in this process, because they have spent a tremendous amount of money building their object libraries. And if they give you the model, then you, another company, could extract those objects into your own libraries to use on your own projects. That is stealing, in simple terms. Within the BIM protocol, the legal and commercial definitions, when you sign up to the contract in this form, you cannot do that. The audit trail shows that anybody has done it. What the government actually does is takes out a license with everybody in the supply chain, that also issues a sub-license to say that everybody else in the supply chain can use this information only for the purpose stated. It all sounds very big and very new. It's what it's always about. You cannot steal other people's designs. You cannot steal other people's IP. It's just that we've had to restate it to build confidence back into the teams to work together. And you will, on every single project, there has to be this employer's information requirement. Inside this document, it will tell everybody exactly what they have to do, the standards that they're going to use to produce the information that needs to be returned to the client at the end of the day for FM. It will all be listed in this EIR. What information do I need from you, me as Mr. Client, to go into my FM systems is enormous. And the use of what is known as COBE, which is the Building Information Exchange methodology, is also built into this. I'm not going to go through COBE in any detail, but I'll just give you a little bit more information about it later. So everything is laid down. You will know how to do this. And you'll have noticed so far, we haven't seen a code system or a walkthrough or a building or used any software. This is all that process. So, this is the diagram that sits inside PAS 1192. And it's actually made up of two diagrams. The blue circle, quite simply, is about information management. And if we follow that round, the client wakes up in the morning and says, I've got a need for something, I need something. I'm not quite sure what it is, so I'm going to have to procure somebody to help me to produce the brief. So the client writes an employer's information requirement for that specific piece of work and puts it out to tender. Anybody can tender for it, and the response to the EIR is a thing known as the BIM execution plan. So you get a document that says, this is what I want you to do, and there is a template called the BIM execution plan, which you fill out to show how you, your team, is actually going to answer those questions that the employer has asked. And those questions have to be answered at these stages, 1, 2, 3, 6, and 7, the red balls at the bottom. Also, the client will only procure possibly what he needs at any given time, hence the disjointed arrow down the bottom here, because if the answer to number 1, which is CapEx sign-off, can I afford to do this, is no you can't, then that's where the project ends. If you get through the gate, CapEx is okay, then you move to the next stage, which is setting up and employing your team. So the EIR is written again, goes out to the BIM execution plan, and when the contract is won, then there has to be a project and a plan developed to show the client that you know exactly how long it's going to take and to demonstrate that you have the resource, people, equipment, whatever, to actually do it. So what we're looking for now at the beginning of a project is to make sure that the teams have the capability and the competence to deliver the project requirements before we start. So many times up to now, people just tick the box. They only win 1 in 8 tenders, so they just tick it. If they win the project, then, oh gosh, the heck breaks loose. Do we have to get enough people? Where are they? Where can we employ them from, or whatever? This is saying, no, if you want to do this job for the government, you must have a team already assembled. If you don't, however, you must have a plan to show how you're going to find these people, employ them and educate them, and bring them up to the level of competence and capability that you need to deliver. So what the government is looking for is an assurance that they've chosen the right people that can deliver this project first time. And so it goes on. 3 is target price. We now have a target price, we've done the detailed design. It's a go in all senses of the word. Go ahead, let the contract, construct it and deliver information to number 6. Between 3 and 6, theoretically, there is no need to answer any more questions. All the answers have been given. What you are doing, now we go to the supplier's information exchanges, you will see these little arrows going around in a circle. This is the iterative process that we go through in design and into construction and into handover and beyond. Because once that data gets into maintenance, what usually happens is nobody maintains it and it decays. And so the longer the building is there, the less information you have about its current state to help you maintained. So the whole process, even into AIM, or the maintenance of information, this is the asset information model, the processes of managing that data, how change comes about, knock the wall down, put another door in, put another window up there. Information that model must be kept up to date. So everything is managed around that blue circle. Here, what happens is once the building's been in operation for quite some time, and information is growing, it may be decided that you need to do something with that building, a change of use. So it's no longer a university, you're going to turn it into a hospital. How do we do that? We have to assess the cost of doing this. And so the data in here is then mined to answer some questions to see what they should do with the building. So the assessment process says, should I convert it to something else? Is it economically possible to do that? Or do I knock it down and rebuild? Or do I knock it down and not rebuild? So information in the life cycle is used to assess whether they're going to build something new or add to it. So it is a virtuous circle in as much as it does the information eventually comes back into the project site. The whole process starts again. Okay, we want to leave some time to allow you to ask questions. I think we've got about 5 minutes or longer to go to a question and answer situation. I should press on. Anyway, the green bit, through these, this is the RIBA or the CIC stages of work. 1, 2, 3, 4, 5, 6, 7. The reason why we've numbered them is that other plans of work by the RIBA, by ISRIA, by ICE, have different names for the stages. But there are still 7 stages needed in all. It just happens to be the process you go around. What you call them is up to you. There is work that you have to do in each one of those stages to answer those questions. So we've allowed people to change and put whatever words they want there. We've numbered it. That is known as the common data environment, the process by which we manage everything and share all of our information as a collaborative activity. We stretch it out. Basically, all this means is we have this process which will come in. Up to now, we've had a series of standards and methodologies that all push information to the end. There is no plan, in the way we used to work, to know what the client needed. So the client, the employer, has to be fully engaged. They have to tell us what they want delivered so that we can assign responsibility to individuals in the supply chain. There is a responsibility matrix to deliver certain types of information and answers as we go through the process. So we now have a push-pull type activity. The client is involved in getting what he needs delivered, not just the industry supplying what they want. So that's all that diagram is really saying. We bend it round to the one above, it fills up the same thing. There is also the thing about how data evolves and how the models evolve. At the start of the project, you may work with schematics. This represents a pump. At the next stage, you may know roughly what that is. Very generic pump. It's got a maturator on it. It has some very basic information associated with it. I can now find one of these. I can purchase one of these objects. I've got a bit more information. I've bought it. I've installed it. I've got even more information, and I deliver it with all of its associated information. That is information that's associated with the pump for just the purpose of 3D modelling and to extract certain types of information. There is, along with it, a whole raft of other information that is associated with the object rather than being part of the object. It's important to understand this. There is a minimum appropriate amount of information within the object model, and there is a whole raft, an enormous amount of data that sits in an external database related, pointing at the different objects. So you can get to that information through the model, or you can get to the model through that information. Why are we doing this? Most of the CAD BIM systems that are out there at the moment have a problem. And certainly one or two particular pieces of software have bigger problems than others. If you put all this data into the model, it becomes so big that all of your systems slow down. And we certainly found that once those models get beyond 200 megabyte, some people have gone to 500 megabyte, your systems will continuously fall down. If for no other reason that the bandwidth you've got supplying your office when you're transferring and sharing this information with others is quite small, and your ISP provider only allows you 5 minutes of uptime or downtime, and it takes you 20 minutes to get the model up there into the cloud or wherever, you know you are not going to deliver that model. Because you have to start your projects with the end in mind. What I mean by that is, the information that you're going to attach has to be managed in such a way that it's not going to impact on the performance of the 3D model. So these two have been separated. COBE is the means by which you manage and deliver information. So although you've got that little group with the red bars on it, little sheet there, over on the right hand side is the COBE file. Basically all it is an Excel spreadsheet. And the schema, that is, what information you have to supply for each object, is based on the IFC, the Industry Foundation Class schema. That is an international standard that tells you what information must be delivered at any time. All of the data is put into that COBE file, this flat pack database. The reason being is that we don't know what systems people are going to be using when we hand the information over now. We don't know what they may be in the future. This is the simplest way of delivering information that can be unpacked and rebuilt in a database now or later on. And it's been proven to do that very well indeed. The problem of interoperability remains in the graphical representation that the data, no matter what software solution you're using, should be transportable and exchangeable through the COBE system. I'm not going to go into that today. There's a slide in a minute. It'll take us much more than an hour to think about it. Other documents, very quickly, the CIC Professional Indemnity for BIM. I can't share my information with you. The insurers say, yes, you can, as long as you are using the 7 documents that I've put up there. If you use any other standard, bespoke standard, known as my standard, and I'm sure you've got one, and you've got one, and you've got one, are no standards whatsoever. They are not insurable. The insurance companies like BS 1192-207, because it has been tested, it's measured, and it knows it works, and it also assures that responsibility is assigned to all of those in a contractual way. There are a lot of BIM standards on the net which you can download for free. They may look simpler and easier to use, but they do not have the rigour that BS 1192 has been through. It works, it is insurable. Any other standard that you use on your project, if it has not been through that rigour and has not been listed, you must inform the insurance company of what you're doing. They will then assess to see whether you're using best practice or not. And it's quite important to understand that, and that's all laid out in this document. For the overwhelming majority of consultants, this will not be a particular issue, and no insurance market with which we have spoken has given any indication that level 2 BIM gives rise to significant concerns. So getting rid of the block, I can't share it with you because you must steal it, I don't want to share it with you because all goes away, there are no excuses, you can share it, it is insured. So we've got rid of that block. The next document is the role of information management. I must emphasise it says management. It doesn't mean to say there is another person in the process. At the moment, we're inundated with BIM somethings, or BIMabees, whatever you like to call them. I'm a BIM manager, I'm a BIM consultant, I'm a BIM expert, I'm a BIM everything. I haven't got a clue what BIM is as we reach this point. To me, it's architectural, structural, M or E or P. Technicians, engineers, qualified, chartered, whatever. There is no such thing as a BIM charter. I don't know what it is. Certainly when I worked on the drawing board, I didn't call myself a pencil engineer. And that is the stupidity of what's happening at the moment in the industry. Everybody wants a title so that they can get on. Everybody will have a title when they can do the job that is needed to deliver this. So in all of these documents, you will only see BIM mentioned in the context of particular responsibilities, which will be defined as management and not as managers. In fact, there is only one BIM expert, I think, in the country at the moment. That's me, because I do have it after my name which says an old BIM expert, so we can go along with that. So I have to do that sometimes, because they keep showing me and telling me that they've all got BIM in their title, and they don't actually know them. Okay, what we do have out of this management activity are roles and responsibilities that were always there, but have got lost in time. Project delivery management, project information management. These are functions that somebody has to be appointed to do. In old money, the project delivery manager, it used to be called the design coordinator, and is most likely the person that's going to carry out that role anyway. Sometimes known as the project manager or just the design manager. But there is somebody already there. They have to take on the responsibility of project delivery management, and they have to take on the responsibility of information management. What does that mean? It means that they have to set up right at the beginning of the project who is going to deliver what, in that diagram I've just shown you, and when you are going to deliver it. So the IM is the what, and the delivery management is the when. You are going to deliver this information at this time. I need it. If I don't get it, somebody else is going to get it missing. So the project information manager starts to have a big responsibility for the role of project information management. In the team, there is an information manager or information management as well. Why is it there? Because the task team manager, to effect change, must check, review and sign off everything that is produced and make sure it's fit for purpose before they share it with others. If that information is inaccurate, then all information derived from it will also be inaccurate. So it must be checked, reviewed and signed off. Which is why I have this book on the desk. Because everywhere, in every walk of life, we do not review, check and sign off what we do is fit for purpose. This is the BSI Guide to Building Information Management. 3 months to write, 9 months to deliver. And a lot of time was spent with printers in making sure that this document was fit for purpose. And as such, we decided to colour code all of the processes so they follow all the way through and it's much easier to read. So it was all signed off, checked, we run the galleys, we signed those off, everything was perfect, run. They did the print run, they started to sell it on the open market. I didn't get a copy, don't know why. I bought one. And I opened it up and immediately phoned the British Vendors Office and said, have you checked this document? Not a problem, Mervyn, it's really good, like the colours, it's all turned out really well. I said, okay, now open it. And what they found was that it had all been printed in black and white. Okay? The point of this is that that was a 1,200 book run, which had to be pulled back and scrapped and rerun. The profit went in that one activity because nobody checked it when that first one came off the press. And the moral of the story, really, in some ways, is unless this goes to about 5 runs, they are never going to make a profit in producing this book because they didn't check it before they sent it out and shared it with others. So it happens everywhere. We all do it, and we have to stop it. The information manager down here is making sure that the task team manager, or the design manager, or the team leader has signed off all of the information. He has checked it, reviewed it, and signed it off. If he doesn't, then the information manager is responsible to the project information management role and tells them that they are producing information and sharing it with others, and it is likely to create errors. So there are policemen, if you like, built in to the process. There are information manager on the client side. Somebody has to compile the information to tell the supply side what they have to deliver. There is an information manager there. There is a project information management role on the supply side, and there is information management at each of the task levels. Task is just another name for any discipline, architects, engineers, MEPs, or whatever. A generic term. I won't go through that. Oops, how do we go backwards? Right. At the heart of all of this, very quickly, is the common data environment, which is this diagram. What it is if we draw a horizontal line between the top two boxes and the bottom two boxes, is we had to generate an environment whereby we could allow people to collaborate through the work in progress to shared area without any finger pointing, without any real contractual obligation. Obviously, they had to make sure it was right, but we wanted them to talk with one another, we wanted them to collaborate. We didn't want them to defend themselves behind their barriers as they traditionally did. All they had to do was, in work in progress, work in their own office, with their own software, with their own system, using the same processes that I've been talking about within their office. So you see those little four boxes up in the top right-hand there, usually known as WIP, work in progress and work in progress. As they generate their information, they have to, the leader of that team, the task team manager, should check it, review it, and approve it, and give it a status. This information may be used for this purpose and no other purpose, and share it. It's then referenced backwards and forwards around that process until they reach a milestone, where they then have to publish information contractually as drawings, documents, models, and the code file as well. And the archive is the thing that keeps a record of every single transaction up there, every single transaction around the loop. We can always go back to it, and that's why the lawyers and the insurers love it, because it tracks every decision that was made, and we can roll back through it to find out who didn't do something that they were supposed to do, or in the event of a dispute, we can sort out what actually happened and who was responsible. A totally auditable process. And that's now been extended. So the centre of this diagram is work in progress to shared, shared to documented, delivery through the bottom here, everything that gets passed and has to go across the gate has to be verified and validated as it comes into FM, into the asset model. And the way in which we also build in a check is that as they deliver that information, a live model, a rendition, that is a clash rendition in the viewer of choice, if you know what those are. There's a lot of jargon here, I know, and we will most likely have to give you other information. Unfortunately, it's unavoidable at the moment. But we also want delivered at that time is a point cloud survey of the actual project that was being delivered. We don't want anybody to use it necessarily to check their model. All it's there for is if we find that the model was not kept up to date using the processes at some later date, we can actually use the point cloud to find out who didn't do it, and they will most likely get struck off the government's list of people that contended for the work. So there is a check built in. And then into this piece, which is BS 1192 Part 3, which hasn't been published yet, so we won't talk about that. The diagram has been extended because everybody looked at the diagram, and the industry being what it is, tries to avoid doing so. So they looked at the diagram, the four squares, and said, it's only for designers. I'm a specialist designer, I'm on the contractor side, I don't have to do that. I can carry on the way I always did. No, you can't. Because once the contractor has the contractual drawings, which are fit for design completion, he assembles his team. He would already have assembled his team through the EIR and the BEP, and the specialist design team, the blue boxes on this left-hand side, work with the professional designers, sharing the same model information and the same extended information. They are collaborating on the same database. What the specialist designers are doing are increasing the level of detail in the model. Design is intent, the specialist is what I'm actually going to build. And as I build it, I'm going to check it physically on the site to make sure that it was defect-free. It has to be within tolerance. Now, every building project is specified with a building tolerance. And that model has to be updated and signed off before it's handed over, and is known as the construction record model, and with it will come the COBE construction record data. Graphic data, two separate deliverables. So the process has now been extended into AIM and through that assessment you saw on the life cycle diagram. It's all been built back and extended through the PAS. So we now have a standard not just for CapEx but for the whole process. One of the things we're looking at is clash avoidance, not clash detection. So the way this works very quickly is I produce something, I go through a whole series of checks, I sign it off fit for use, I give it a suitability, you may use this for spatial coordination, you share it. The structural engineer comes along and references into his area the architect's information from the shared area, the one that's been signed off. Builds his model in context, clashes it with the architectural fabric, makes sure that there are no clashes, and then shares his model in the shared area. What we have in this process, and the MEPs do the same thing, in this process what we have is clash avoidance. It's done as part of the way in which you build the data, not clash detection. It's carried out by some organisation thousands of miles away, and a great big file that you have to manage on a Monday morning to see who's got altered their model. In the BS 1192 process, you do not have to do that. It's about clash avoidance. If you have any questions at all, we've got about 16 minutes. There is some more I could show. But if you have any questions, please just shout out, and I'll do my best to answer them. What I'd hate to do is to leave today with lots and lots of questions hanging that I could answer quite simply. If you have anything that you don't quite understand about the processes so far. Does anybody want to ask a question? It's at this point I usually scare the life out of everybody by saying, if you don't ask me a question in the next 5 minutes, I'll point at one of you and ask you a question. No, it doesn't scare you. I may well do that. So think about it. Okay, what I want to do is, I can get my cursor to come down. Right. How does this all work? This is the commendatory environment. The check gates are the grey, they're boxes. That is work in progress. That is shared. That is published. And down here is the archive. So you start off the process. Somebody opens a file, architect, let's say, and sets the coding to P1.1. That is preliminary model file number 1, revision number 1, and this is going to be my first time, my first version of this model, and I set the suitability to 0. If it's got S0 on any of these models, you may not use it for any purpose. So the architect produces his models, in this case there's actually 5 models there, stacked one on top of the other. I won't go into the way they're broken down, but you can see these are kept as quite small models. As I said, you need to keep them to a size so that you can share them with other people quite quickly through the pipes and networks that you may have available. Once he reaches a certain stage, he puts it up for approval. Checks are then carried out by the task team manager first of all, checked by the the information manager, checked again by the task team manager. He says what may happen to it. Yes, I'm going to share it. I keep it to P1. I've taken away the versions. I've taken away the 0.1. It's a whole number. And I've set the suitability, the status, to S1, which means whoever wants to use this information, you may use it only for spatial coordination purposes. So you, as authors of information, can keep control of what other people will use it for. And it's moved into the shared area. Along comes the structural engineer, sets up a file, sets his file to P1, it's the first one of the day. S0 can't use it for anything. References in the architectural model, builds the structural model in context, That is, make sure that whatever he's doing is fitting. If you remember those blue and red drawings, if something is too big, it won't fit. The interface manager has to go and shout and say, I need more space. Collaboration, let's talk about it, let's make sure it fits. Let's avoid clashes as we produce the information. And I put it into the check area, goes through the normal checks, change the revision, peel off the version, set the status, and so all the information now in the shared area is able to be used by anybody for spatial coordination purposes. Now for the MEPs, they do the same process, check, change the revisions in the status, make it available. Okay. What happens now is the cycle continues. The architect wants to make a change to his model for some reason. So he references in the other two disciplines models, sets up his file again. It's number 2 now. So it's moved from P1 or P01 to P02. He's starting a new revision cycle and he set it to S0. If anybody gets this information, it's got S0 on it, you cannot use it for any purpose at all. Goes through the whole process again, checks it, reviews it, and unfortunately it's not right, so he rejects it. It is rejected in the process. It goes back in, it's now version number 2. P212? P0212. So you keep a track of where you were in the process of development. It's also very important because if you exercise the model at this stage, to do an extract, how many doors have I got, how many windows have I got, how much concrete have I got, whatever, that extract, that bill of materials will be related to the version, the revision and the version number. So you keep track of everything. You may want to try 3 or 4 what-ifs. When you decide which one you're going to keep, then you can discard the other versions and then just publish it with the next revision. So the versioning of this, indexing of the information, becomes quite important in controlling other information that is extended from it. He's made the change, he's checked it already. He knows it all fits, he doesn't have to worry about asking any of the other disciplines to change, and it ends up in the shared area P02. You will notice in the archive there is a locked copy of every single transaction. We have a history of everything we've done to get to this point. The insurers are happy. Okay. At some point, the design team, all of them, the leaders will get together, they will review the model, it's reached the milestone for delivery and wants to send it to the client perhaps for review. They will produce a combined model, they will check, review it and agree that it's correct. They will change the status. So now it's S6 for Project Information Modelling Acceptance, which has to go through a client process. So it's actually dropped into the next sign-off box where the client or the client's representative or the employer's information manager will sign it off, accept it as fit to be used for construction. It's now a contractual document and it's published, where the contractor picks it up, possibly in the 2-stage, and will assemble his team to then work on it. So the system itself, the process, is actually quite a simple one. It looks very long-winded when I show it to you like this, but when it's actually working on a project, it is making sure that people are getting information as quickly as possible to try to avoid any additional work or abortive work. We're trying to eliminate all of those abortive work by issuing and sharing information as quickly as we can. Okay. Nobody's asked me a question? Okay. So, as I've shown, hopefully, the process is a simple one and the procedures create a disciplined approach. It is very disciplined. This isn't about everybody in the office or everybody on the project doing what they want. It is a very highly disciplined approach where you have to work towards a delivery time and a cost.
Got a question here.
Please.
What are the implications of BIM on cost, noting that the S-curve of construction normally has nothing at the beginning, very low at the beginning and then ramps up towards the end. Obviously now that BIM has to be carried out at the beginning, there's an awful lot of expenditure needs to take place at the beginning.
Okay.
How is that going to be dealt with, especially with the financial institutions normally releasing money when work is being done?
A lot of perceptions there, if I may say. First of all, why is there an extended cost at the beginning?
I'm asking the question.
No, okay. There is, in reality, there is some cost. I'm not going to deny it. What happens at the moment is the vendors, to some degree, I'm not blaming the vendors for everything because I haven't done during the presentation, but the vendors are trying to sell us software. And they're trying to sell us a process that says use more of my software, use more of my hardware, use the cloud, whatever. And so we get beguiled a little bit by them. And so this idea, this concept, perception is that this is really expensive to start up. And you do find the design houses kicking at it and saying, I better go to the client because I want him to pay me 30% more of my fee so that I can buy better equipment. Yeah? In reality, if you use this process in BS 1192, that is actually avoided, and that minimal charge, the cost that you go to is education and not setting up hardware and software. The reason is this. When we tested all of these things, 1996, where we were building Terminal 5, any of you who's been in Terminal 5, that was the first and the biggest three-dimensional spatially coordinated model ever built. And if you think of the technologies in 1994, 96, they weren't that clever. We had smaller machines, we had very small bandwidth. The servers we were using, we had to use distributed servers to hold all of this information. And what we did to enable us to use the technology to use 3D modeling in the way that I've shown you is to actually cut Terminal 5 up into small bits. So there is no such thing as the model. This is a federated activity where each of the individual disciplines has its own model for its own information and shares it and can view it in context with others. And the viewing process is quite light on computing power. But we also federate the model in each discipline, so we cut the model into usable parts within an office. The idea, if anybody tells you that I work live on my model in the cloud with everybody else, is not true. It's a marketing exercise to a large degree. Because when they work in the cloud all live at the same time, they have to check out a bit of information. I'll check out that wall because I'm going to change the reader. Nobody else can use it while they're doing it. And then when they finish, they're supposed to check it, I'll sign it off, and they check it back in. That is the same process that I've shown you there. But I don't have to do it in the cloud, I don't have to have big bandwidth, I do not have to have big glossy machines. So what you need to do is arrange your data, it's all part of the process, to use the optimum size equipment that you have at the time, and to minimise any of these costs. So it can be done to organise that. There is a cost of retraining, because we're trying to move people out of bad habits into good habits, and that is a difficult task, and it has to be done. Why I say this was all tested and checked and measured on all of the projects that the government paid us for. The cost into the project was around about £15,000 to £20,000, which was the cost of a consultant, myself and others, to go into the companies and train the people in this different way of working. They know how to use the equipment. Yeah. They knew what they had to do. All they had to do was to take smaller models, hand it and check it. That's all really they had to do. So the impact is positive, positive, positive in all of the things that we tested and measured. But there is a perception out there that it's going to be a lot of expense and it's all up front. There may be, and the thing I will concede to, is a redistribution of the fee. You may spend more of the fee at the beginning than you do in the middle. But you don't spend more fee. You actually, and it's been proven in all the measurements, reduce the amount of money you spend out of your fee. Architects, proven and have published it. Neil Sterling, 3D Read has published it, that using this BIM process, this BS 1192 process, he has 25% less iterations to go through to come to a design conclusion. Yeah. So his his investment is actually 25% less in people. That means 25% less in cost. He's not going to say more than that because he doesn't want to give part of his feedback to the client, and nor should he. Because if he has a better process and is much more efficient than others, then he should keep the value that he's saving. Structural engineering, steelwork, doing this and following this process, we get rid of 60% of the pull on the fee. 60% of the pull on the fee was about drawing everything. We no longer have to draw anything. We can transact through the model. So once the designer has produced this model as a byproduct of this analytical process, there is no need to redraft it. You just hand it to the fabricator, and they do additional work, perhaps. But the savings to them in fabrication is that they only have to fabricate once, not 1.25 times, if we stick to the 20-25% thing. For instance, there is a project, a case study which I have here, at Basingstoke Town Centre. It was £1 million structural frame let. The package was £1 million. A 3D model was built. So we can get it on site. Brilliant. We cut out all the drafting and reduced the costs. We got it on site and we then spent £60,000, £60,000 in reworking on site, which escalated to almost £600,000. So there's another part of this process when you build it, you check it, record drawing, and you alter your model immediately. Part of the problem with structural engineering is if the foundations are built too high or too low or slightly out of place, and you don't know about it before you get to site, you have to rework on site. If you follow this process properly, and you make sure you record it, and the fabricator knows at the point at which that concrete's gone hard, where it actually is, he can change his fabrication before he builds it. So he's going to make savings in his process, he's going to make more profit. The client wins at the end of the day because he gets what he said he was going to pay for. He doesn't actually make a saving, he stops spending additional money because the processes are so poor that they generate additional costs. Architect wins, structural engineer wins, the MEPs win. We've proven in this process everybody wins. The margins increase. The client gets what he wants. And that's why the government wants this process mandated. And also Europe and the EU are now looking at it to mandate the same processes into EU projects as well. So be careful of the perceptions. Who knows? Please.
So what you're saying is that if you look at BIM right now, from the vendor point of view, what they're telling you is that if you change something, everything else changes magically.
Does it really?
What they say, the difference between BIM and a 2D or 3D general draw is that if you change something in a view, for example, you have obviously need to change all the other connected views.
Yeah.
If you do the same in a BIM model, everything is done. And in a certain way it makes sense, because obviously it's all connected. But if you follow this process, it's actually meaning that I'm a structural engineer, for example, I change something, and then it's not magically changed from the software, but all the other connected, because we're sharing the same information, I'm going to change the.
Yeah, you said one word there. They are not connected.
That's the thing.
They are individual models that you can view in the same space. They are not connected. Mostly there is one piece of software called CATIA, which has a structured relationship, so that the bolt knows where the nut is that belongs to the wheel that's on the car. It's got this totally related database. In most of the CAD systems, or BIM systems, there is no relationship. And so the idea of updating one little model and everything else gets updated, or the other models get updated, does not happen. It does to some means affect the drawings you generate, but you must be careful because in practice, the drawings that are generated by cutting the model do not give you the level of detail that you would expect from a drawing for construction purposes. Because the level of detail in the model may only be taken to, let's say, 1 to 50, what we would normally have done on a 1 to 50 scale drawing, where we really want to get to 1 to 20. What people then do is they change the drawing and they change the dimensions on the drawing without changing the model. So now what we have is a whole lot of information that is now uncoordinated. So be careful what the vendor's saying. Follow the process. It stays not connected, but at least the changes are made by the people who have the responsibility to change it, and it's not just changed automatically. There's one company on highway design has said that what they really want is a piece of software where they drive the highway through the countryside, all of the bridges, all of the gantries and everything else are related to the centre line, the drains and everything else. So if they move the road, everything else moves with it. That is one heck of a task at the moment in any system. I'm sure we may get there someday, but it's a long way off. So the vendors themselves are overselling the possibilities here. And you can go to any meeting, certainly any discussion on IFCs, for instance. I am a board member of Building Smart, which is developing these things, so I know what the problems are. IFCs at the moment will only give you about 80–85% interoperability. There's a little way to go before it's 100%. So that in itself creates problems. We cannot share everything 100%, but the vendor will tell you that his software has been tested and he has the capability of exporting 100% an IFC model. Ask him if he re-imports it, does he get the model that he sent out? Because all these tests up to now have been carried out on export, not on import. They are now starting to check import as well, and there are problems. So, if you have a Bentley model or a Revit model that you export in IFC, and you then re-import it again, you most likely will not end up with the same model. In fact, if you have two, I'll use Revit as an example, two Revit systems sitting side by side, and this one have the same revision, but a different version. So this one is one version ahead of this one. You export IFC there and import it here, you won't get a full model anyway. Because these two are also incompatible, let alone the IFC file that's going out. So whilst there is good value in understanding this interchange and exchangeability, you must also understand the limitations so that you can manage out any of those limitations that of course. Things are not as bright as the vendors would like us to have it. And how can I say that with some assurance? If we knew the one piece of software that did this 100%, there would be no need for all the other software out there. There isn't one that you can go, that one does everything, we're going to buy that. They all have problems. But you need to understand those problems. Anything else? Oh. Okay, so I think sorry.
What's there for the client apart from 3D model and cost saving? Because client won't spend much on the software initially, because it's going to increase the cost of the whole product.
Once again, I think my answer here, I'll say it, I'll perhaps put it in a slightly different way. Why would any architectural practice at the moment, or any engineering practice at the moment, where the client isn't paying for the software, why do they, every single year, go out and buy the latest version of that software? If it doesn't save them money, forget the client. Why would you buy a piece of software in your business that you own, that you're trying to make a profit on? Why would you buy a piece of software that you can't afford? What I mean by can't afford is, if it doesn't save you money, and hopefully increase your profit margin, why would you buy it? The client is a secondary situation. He is going to ask you to do something, and if you can do it better than anybody else, you win more work and you get more profit. So once again, this whole idea that there is a big cost up front, you really have to look at it from a business point of view, what you need to do the job you're being asked to do, and what sort of systems and networks you need to do. And at the moment, unfortunately, there is a tendency for people in the position of ordering those machines to buy the latest Porsche, whether they need it or not. And unfortunately, it may seem silly for me to say it, but everywhere I go, I've just bought the latest computer. well, I don't really care. Did you get any savings out of it? Has it brought you more business? What is it doing? Other than you being able to market yourself and differentiate yourself by saying, I've got the biggest in the Chinese. And people really must look back at these processes and methodologies. The profit is there, the profit is available to everybody. If the UK doesn't pick up on this, then there are a lot of people out there, and at the ICE conference earlier this year, there was a consultants organisation from the Philippines stood up and said, I am using all of these processes, I'm using the latest technologies, I know how to make these work, and I can do your job, Mr. Client, 25% less on the fee. The competition is there. We have to pick up in the UK and use it as wisely as others are finding that they can use it at their own. Not everywhere is doing it. So I tried to say not everybody is at level 2, but there are real pockets, real good work going on. And there are companies that have invested in the education to use the technologies that we've got to best use. So once again, it's looking at what you're trying to do, how you're spending your money, and what the returns are. In fact, silly argument, this one I'm going to give it to you anyway. I was at a demonstration last year where a major vendor said that using this software, you can now get your drawings at half price. You can produce drawings at half the price you always used to produce them. But if that's true, you buy this software because if everything is based on the cost of your drawing, then you should buy that piece of software because you're going to get it at half the price. My question to the person demonstrated was, how much did the model cost in the first place? Because if I build a model and I only want to slice one drawing off it, that one drawing could be very, very expensive indeed. Yeah. How many drawings then, was my next question, do you have to slice from your model to get them for half price? Because once you tell me that, I would suggest you peel off the same amount of drawings again and get them at a quarter of the price. And that's not what this is about. We don't really want to take any drawings off at all. We want to build 3D models, we want data, we want to share it in the best possible way. We still have to produce 2D representations at the moment, but they will get less and less as time goes on. But I'm really just trying to exercise the idea that you really must know what you're buying and the purpose for what you're buying it to satisfy the client's conditions so that you end up making profit. Not just reducing the client's costs, but you making profit. This is all about everybody in the supply chain making a profit out of it. And not forgetting the obviously where you are and where you will be in a few years' time in FM, that you getting these systems in place and telling people what you really need, get the best quality information that you can possibly get to carry out your job in asset management and FM. And that means you have to manipulate that information with the best type of software at that time. So we're looking for best quality information inside a system that you can manipulate, mine the data to do your job better as well. And this is about assessing what the software can really do, which is the best one to buy for you. Yeah?
The NEC contract has been around 20 odd years and still they have problems with working practices and working within the ethos of what the contract is designed to do. Why is BIM going to be any different in 2016?
That's my question. Will BIM be any different? I think it will be. The NEC contracts are being looked at again. There is a greater understanding coming about now of what this whole thing, the holistic BIM that I've been talking about, not what the vendors are talking about, this holistic process that the government's asking for. And the NEC contracts are being changed to cater for that. The BIM protocol also helps in the way in which those contracts are going to be set up. So they will come around, and the JCT contracts and the collaborative working contracts, they're all learning at the moment, and there's still adjustments to be made to those contracts. If we push the industry a bit too fast, then we may have a kickback. But all of these things must all go together in parallel. We are all learning. quickly at the moment, but we are learning. It's not a done deal. We've still got a way to go. We need to understand it, and we need to collaborate in what we're doing there. Which is why lots of people, and my colleagues here, are involved in helping move this stuff forward. It's the biggest research activity that's ever been carried out, to be honest. But it's worthwhile at the end of the day. If there are no other questions, I think we're just on our time limit. I understand that some of you have to get away. Thank you very much for the questions. If you have any others, if you'd like to give them to Christine, and I'll email them anytime. Okay, thank you for listening.
For those of you that are in management, if you want some feedback on your performances that you put in, you best stay. I'll let you shut down. So just hang on a few minutes. Obviously, there's some people in here who don't receive feedback on that. So we'll just wait a couple of seconds. We'll just stop that. And I'll give you some generic feedback. I've looked at about a quarter of them now already since you handed them in. So I'll give you some pointers on what's wrong with the risk registers that I've seen so far. And what you might need to change to get a better mark for your summative. So this is your last opportunity, particularly part-timers, to see me. So you better hang on. I will make it brief.